Here, and I'll explain it to you. I didn't really show this in the other class. We used to, in this chapter, talk about graphing in 3 dimensions. We used to graph things in 3 dimensions, and it's not something that we do a lot of anymore. What we could have done, if you guys remember when you would plot stuff in just a regular 2-dimensional plane, the intersection that you guys found, like the solution set to these things, was a coordinate where the 2 lines intersected. What happens now, when we're talking about 3 variables, we're talking about where they land in 3-dimensional space. For example, just so you guys understand what it looks like, if we happen to have an ordered triple of, let's say, 2, 4, and -6, it goes x, y, z, respectively. Forgot the word. Now, yeah.
So this is like the problem 5 on the.
No. Yeah. Oh, yeah. That one had 3 variables, didn't it?
Yeah.
Yeah. But that one isn't. It's system. It's a linear combination. It's a lot easier to do systems with 3 variables on a linear program than it is on here. It's easier to do it that way because you're graphing.
That was easier than what we're about to do.
Yeah.
Because that was nuts.
Well, no, not really. I mean, because it's just that was 3 equations with 2 variables. That's easier than 3 equations with 3 variables. I'll show you in a second. So what happens here, if you were going to plot this before, you're looking where the intersection of 3 planes would have been. X comes forward 2. Y goes, which way is Y positive? Y is positive that way. We go to the right, 1, 2, 3, 4. And what you do is you kind of draw it out where they would meet. They meet right here. From that spot, we have to go down 6 from here. So it's 1, 2, 3, 4, 5, 6. So those 3, that point in space is plotted right there. So, like I said, we don't do that anymore. What I want you to do is all turn around and look in the corner. Do we all see a window wall, a back wall, and a ceiling? A window wall, a back wall, and a ceiling. Do we all agree that they all intersect at one point? Okay.
There's all like square that
Yeah,
jumps out.
can we do like that corner?
Yes, let's do that corner. Does that make you feel better?
Yeah.
Okay. Anyway, that's why we don't, it's over there. That's why we don't worry about plotting those anymore, because it's a big pain. Really no reason to plot in 3 dimensions. But what we will do is we will find the intersection of these guys. We are not graphing these. No. Here's what happens. We are still doing linear combinations, and we're working with linear combinations, substitution, all those types of rules, elimination, things of that nature. But what we want to be able to do now is use one equation to eliminate one variable and the other 2. You're going to find out real fast that you want to try and use equations for elimination that have a variable already with a coefficient of 1 or coefficient of -1. It's a little bit easier to use. Now, I know you guys are still writing. I don't want to go too far on this because I'm going to shrink this down a bit so you can kind of see. It does get messy. If you've got crummy handwriting, you're not going to like this. You have to be it's kind of tough to see where everything goes. Does everybody see a variable right smack dab in the middle that has a coefficient of -1? The -y, very good. Now, if I wanted to eliminate the y coefficient and variable in the first equation, what would I have to multiply the second equation by? 2. So here's what we want to do. We want to pick something to eliminate. I'll move this over here. I'm going to take 2 times the second equation, and I get 4x minus 2y plus 6z is 8. I just multiply that second equation by 2. To that, I'm going to add the first equation. Okay? All I'm doing is is take, now, I have same coefficient with opposite signs. Just like we do with two variables, two equations, we would add them together. When I add them together, I now have 7x plus 10z is 19. You want me to pull that one back up?
No, I thought that your z's were greater than or equal to signs.
No, we will not shade problems like this, don't worry. Could you imagine how nasty that would look?
Pretty gross.
Very gross.
Don't not.
Okay, now, is everybody in agreement that we have now eliminated a y variable?
Yes.
Now, let's eliminate the y variable in the third equation, once again, using that second equation as, I don't know, like our pivot. Fly, right?
Yeah.
Right, 3 is to get rid of it again.
Yeah, well, because we're just going to reuse this equation. What you want to do is it's a kind of a trick. Once you pick one equation to use to eliminate the other ones, use the same equation. You'll be less likely to make a mistake. Can you get fractions and decimals and all our stuff with these problems? Yeah. Tonight, the problems I'm going to give you, it's going to be integer value. So you know if you start getting fractional amounts, you did something wrong. Is that fair?
Yeah, that sounds about
You can still get, just so you know, you can still get no solution or infinite solutions. No solution would be something like 0 equals 4. It's a false statement, right? A true solution would be 2 equals 2. And that would be your hyperbolic paraboloid. Otherwise known as? Good. You guys will learn one thing in this class. So, once again, take the second equation, multiply it by 3, and I get 3x minus 3y plus 9z. Oh, excuse me, 6x. Thank you. Sorry.
What are you doing? What is this?
I'm taking the second equation and multiplying it by 3. Why 3? Because now with this third equation, 5x minus 3y plus 5z is negative 1. I have same sign, same coefficient. I can subtract. Very good. I can subtract all 4 of those.
So it's just to get rid of y.
Correct. Because now once I get rid of y, I get x minus 4z is 11.
Shouldn't all of those y's be positive? We're subtracting.
I'm subtracting.
Oh. Yes.
What's that?
Number 4 is equal positive.
Yeah. Plus 4 is equal.
Thank you. Thank you. Sorry.
Wait.
Yes, sir.
So, since you're subtracting, is it kind of just like you're multiplying the bottom one by -1?
Yeah. You can do that too. I mean, if you wanted to do that. I mean, I could have multiplied the first equation by -3 and just added them if I wanted. All right. So what I'm doing here, guys, is I'm trying to eliminate one variable in 2 equations because now you're left with 2 variables in 2 equations. What's that? No, and I'll show you why here in a second. Yes, sir.
Why did you choose those last two? Why did you choose those equations?
Why did I choose those? Once again, the reason I chose this one to start with is I already used it to eliminate y in the first, so I'm going to reuse that one to eliminate y in the third. I don't know who's next. You're closer.
It should be 13 instead of 11. Let's keep it's subtracting -1.
Yeah, gosh,
It's been a long day. Yeah.
I didn't know about this.
So have you figured out where you're going to make your mistakes? Adding. Yes, sir.
I don't understand. Why is -3y minus negative? Oh, I see. Okay, never mind. It was this make.
Same change, opposite.
Key flip change.
Key flip change.
Oh, yeah.
Oh,
Okay? Now, everybody see how we're back at two equations, two variables? Now you use your linear combination method again. So if I want to, which variable do you want to get rid of? Do you want to do a linear combination or do you want to use a substitution method? Yes, sir.
Wait, for the second equation that you did, x plus 4z equals what?
13. We had 12 minus a negative 1. So it's 12 minus a negative 1. So that's where we got 13. We can do substitution, or we can do, or I can just multiply the bottom one by negative 7 if I want. I'll use substitution. So if x is 13 minus 4z, I substitute in here. And I finally have an equation with just one variable. What is that, 91? We'll move this up over here. 91 minus 28 plus 10z. Add 18 over there, subtract the 19 over here. It's 72. We have 4. We are 1/3 of the way complete. But the last 2/3 are very easy because you did all the hard work now. You know that one of the ordered triple, the z value is 4. Do you have some very easy way to solve for x now?
What just happened in the 7x plus 10z equals 19?
What I did here, he overpowered us and told us to use substitution. Instead of linear combination, since I had x with a coefficient of 1, I subtracted over. So x is 13 minus 4z. And I use substitution to here to solve for z. There are multiple ways of setting that up. We could have multiplied the second equation by 7 and subtracted. We would have gotten the exact same result.
Okay.
Okay. Yes, sir.
Instead of finding x, you just plug z back in.
Correct. In order to find what x is, we already know that x is going to equal 13 minus 4 times z. So x is 13 minus 4 times 4, otherwise known as?
-3.
Excellent. So the first problem, or first variable, is -3. So now I know 2/3 of my problem. I just keep going. I know what x and z are, so I go all the way back up top to one of the first equations. Does it matter which one I substitute in to figure out what z is? No. So 3x plus 2y plus 4z, 3x plus 4y plus 2z was 11, I believe. Yeah. 2y, 4z, 2y, 4z. So now, -9 plus 16 is 7. 11 minus 7 is 4. 2y is 4. See what I mean by it's very simple if you're not careful to get lost in your handwriting of where things go?
Yeah. My notes are at the
2.
Yeah, this takes so long.
Outline.
Yeah, there's well, this is the first one you've ever done, so the second one will get easier. The third one will get easier after that. Yes, sir.
You just plug v into all three equations, make a few variable equations.
Minus 4 is because you at least like I tried to get the number in here.
You still have to do kind of what we're doing. Because once you go in for z, you still have a system equation to go for, and that's what we're doing here. We're just eliminating one to start with, and then it forces you to solve for one variable right away, and you already know what the other one is, and you know what the other one is. So you're working your way down to work your way back up.
Like, I put it back in for Z and all of them, and then put, like, made it 2 variables.
And it'll work. It's just as long. It's gonna take the same amount of time, really. All right. All right. Let's try again. What's that? What was y on that one, guys? What was it? 4? 2. Now, there is no written rule that tells you which one to solve for first. It is completely up to you guys to choose. There's no right or wrong answer. Some methods are quicker than others.
This is so dangerous. Can you skip the second equation and just do 1 3?
What?
Yeah, do you have to go into, no.
Anyway, can you go 1 and
You can
3
pick-
and then
If you want to eliminate x, you can eliminate x. If you want to eliminate y, you can eliminate y. There's no rule that says you have to use one equation to solve for the other two. I'm trying to get you guys to think about what's the easiest one to use to get rid of the other two. And anytime you see something that has a variable of 1, especially a negative 1, use that one to eliminate the other two. It's a little bit easier.
already messed up?
You didn't mess up. Continue what you're doing. I'm sure you're gonna get it. Seriously. Which one were you going for? Y's? Fine. Eliminate x's. You're gonna be okay. You multiply the top one by 3, subtract the second. Multiply the top one by 2, subtract the third. You're gonna get the same result as we do. I guarantee it if you don't make any mistakes.
I multiplied the first one.
It took a minute, anything.
Well, it's true. All I'm trying to get you guys to think about is what is the easiest way to. You guys should be good at this, trying to find the easy way out.
Honestly.
Seriously. If I want to find the easiest way out of this problem, I'm going to eliminate z. Once again, everybody see how it's got a -1 coefficient on the first problem?
Yeah, I did.
That's
That
fine.
was a bad idea.
That's
It's not.
scary.
It's not. Seriously, you're going to get the same answer.
I think that's the.
Well, let's start with z, okay?
Yeah.
If I multiply the first equation by 2, I get 2x plus 10y minus 2z is 32. To that, I'm going to add the second equation. When I add those two together, what happens to the z's? Gone. Goodbye. See you later. 5x plus 7y is 44. Do you agree? To eliminate the z in the third equation, what do I do to the first equation?
Multiply it.
Nothing. Why? I'm getting rid of z's. Why? -1 and 1. So I have x plus 5y minus z is 16. 2x plus 4y plus z is 20. Add them together. 3x, 9y, and 36.
This is what they do in Guantanamo Bay.
Yes.
Alright, so can we just.
Where did what go? The top equation? I just took this equation here and I added to this one because the z's go away.
You get to solve the z twice.
Yeah, if I eliminated it once,
I didn't know that's allowed.
well, we're not solving for it.
I know, but.
We're not eliminating, we're not solving for it. What we're doing is we're eliminating it. We're getting rid of it. We're trying to pick a variable in one equation to get rid of. And we use one equation to get rid of it in the other two. Gentlemen.
You can answer those.
Okay.
In
It's fine.
Alright, so now we just. gonna take the answer from the one up there,
Uh-huh.
the ones, the 3x plus 9y, do we subtract them or add them?
Right here?
Yes.
How do you want to get rid of x and y?
We have them multiply them.
Yeah. You can do some sort of linear combination, or, oh wait, what do you got? Take a look, what do you got?
Oh, it's, well, on my paper, I eliminated that.
Okay.
Oh, this is.
That's fine. 0 through 2. You got it. Yes, sir. You wrote down the problem. Your handwriting. Oh, I see what you're doing. Yes. That's fine. You're doing fine. Continue what you're doing. There's nothing wrong with what you're doing. Nothing wrong with what you're doing. Go for it. Finish that up. On this part here, you guys might recognize there's one thing you can do right now.
This is what I've been doing through the problem. I got, right? I put,
You're eliminating the z, so you got, that's your first equation.
I put x in for.
No,
here.
no, 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 no,
I
no.
can't do that?
No, don't do that. You can, but oh my God, you're gonna hate yourself. Don't do that. Eliminate the variable in two equations first before you put them back together. Don't do that method. You're gonna sit, you can do it, but you're setting yourself up for a god awful substitution problem. You don't want to do that. Trust me, you don't want to do that. You're fine. You're doing great. Perfect. All right. So now you know you have one equation here. You've got x by itself, right? And you have the other equation here. Yeah. Yes.
Yeah.
Why did you eliminate the z here? You got to pick the same variable to eliminate. Can't eliminate two different variables. Bad things happen.
Wait a second.
Well, then what's z?
-0.
Is that a 0 or a negative 0? Guys, if you get 0 for an answer, is 0 a number?
Yeah. But it's -0 number.
Yeah, that's what I
If you
mean.
divide it by if you take 0 and divide it by -1, what do you get?
0.
You get 0, right?
Oh, okay.
You did it right.
Yay.
Same thing with Taylor. You did it right.
Yes, I did it
Now,
right.
Wait, so we should do fractions?
no, there should be no
No.
fractions.
Yes.
What I'm seeing in this problem right now is that I have x and y in two equations. There's one method that kind of makes this one a little bit easier than another.
That's what I did.
No. In this case here, can I divide the bottom equation by 3? And I get x plus 3y is 12. And I know some of you guys did this, that you got x equals 12 minus 3y.
I think it was.
Instead of using some linear combination, multiply the top by 3, the bottom by 5, and subtract, it works. I can substitute this in here right now. And I'll get an answer in terms of y. So I have 5 times 12 minus 3y plus 7y is 44. So 60 minus 15y plus 7y. If you were complaining that you got 2 for an answer, you did it right. Add the 8 over, subtract the 14. If you got y is 2, you did it right.
No, I didn't.
Okay?
Why does this require us to
So
so
drowning.
I got next one.
It's a big, giant thinking problem. Y is 2, which means to get x, well, what's 12 minus 3 times 2? What's x? 6. Now, if 6 is 2 and y, or excuse me, 6 is x, y is 2. So up here I have, 6 plus 10 minus z is 16. What's 6 plus 10?
16.
What's 16 minus 16? What's 0 divided by -1? 6, 2, 0. Some of you guys went out of a different way. You picked a different variable to solve for first. You're going to get the same answer.
Your calculator would explode if you tried to put that into y equals.
Well, once again, because it's got 3 variables, your calculator does 2-dimensional plane. Exactly. Okay? Remember, Texas is flat. That's why it's Texas.
My aunt actually
Colorado.
It's so bad.
Was it like,
Man,
20 foot?
No, it's actually not, man. In fact, now, and she doesn't count.
Actually, I'm going.
All right.
Colorado instruments.
Colorado instruments.
Oh, is it like how you?
Let's walk again.
Nameless
Oh,
stuff.
no, let's not.
Okay, I heard
Yeah.
it's like,
Just send these two problems.
Let's take up a whole page just for one of these. You know how inefficient this is?
I know. This is a thicky thing. And guys, like I said, this just takes a little bit of getting used to. There's no rhyme or reason as to which problem you want to start with. It does not matter which variable you want to try and eliminate. Any one of them will work. I'm just suggesting that anytime you see one that has a coefficient of -1, use that one to get rid of that coefficient in the other two. It's just a little bit easier. You don't have to. It doesn't make a difference. What you're trying to do here is just make your lives as easy as possible throughout the problem. It's not that the arithmetic is going to be difficult to do with these. What's going to be tricky is keeping your signs straight and not making a simple mental error like I did with 12 minus -1. It's 13 now. Change.
Why do you keep the first? Is that what you dividing negative numbers? What's that for?
Same change, opposite. Yeah.
Oh, well, come on.
You should, but I got it wrong.
Come on.
Do you guys want to walk through and use the Z again here?
Yep.
Proceed.
Yep.
If I want to get rid of Z in the second equation, what do I have to multiply the first equation by? 2.
Yeah, that's all I'm saying. We should use like a different number, like.
Well, that's why my Z has a tail.
A number, maybe. Is there that you said number this
I did hear that too.
I'll.
That's all right. You understood what I was trying to say.
I don't think he did. He was below the line.
I'm just going to nod and smile and continue adding
Oh.
math, I hope.
A number is just gonna get naughty.
I'm eliminating the value of Z in the second equation by using the first equation. I add those together. 24x 14y is -20. Use that first equation to eliminate Z in the third. What do you have to multiply the first equation by to get rid of Z in the third?
I haven't done that yet. Like, what if you
Wait, is there a certain equation?
You want to reuse the same one?
Yes, like reuse the second one.
No, you reuse the first one, because remember I'm multiplying something by the first one to get rid of the second. So reuse that first one to get rid of the third. So when I reuse that first one to get rid of the third, I got to multiply it by 4 now. We have 36x 20y minus 4z. What do you got?
I eliminated Z.
Okay. So did I.
It's so inappropriate.
Oh, you didn't send it to me. You wrote down the problem.
There it is. And I get the same thing.
So you multiply this one by. You multiply this by 2.
those two. Alright, then you take those two problems. And you eliminate,
I eliminated Y.
are you eliminating Y? Nothing's alone. Just leave it, forget about it.
You're fine.
No,
Then
I gotta solve for Y.
So now you've got two equations.
But that's
gonna
not
solve
the
it.
equation.
Okay.
Then you go take two more equations.
So we're gonna take the last two and eliminate.
Well, you have to do linear combination.
Wait, actually, no.
Multiply everything by, multiply both sides by -1, or divide everything by -10.
I got
X
one
is
more.
Y.
So I got -2, 2, 3.
You're fine.
Wait, so X equals Y.
X.
Negative Y.
And then you use substitution, okay?
Yeah.
Let me finish this one out because we're running out of time, okay?
Yeah.
So here you wind up with something kind of really ugly. But remember, there's more than one way to do this. But remember, on the test, which is Friday, it's going to state, use algebra, and you have to show your work. Yeah.
What? No.
Yeah, you just have like an entire
I don't
page
care.
of the test just devoted to like that.
Yeah, probably. Then you do a linear combination here. You can simplify out. Come on, guys. Multiply the top one by 18, the bottom one by 14, and then subtract. When you do that, I believe you get x. I think x winds up being -2. I believe you wind up getting x equal to -2 in that case. I don't have my calculator in front of me. And then it's just a matter of going back up and solving through. Okay. These take a little bit of time. They're not the most frightening things in the world. Yes, sir.
Alright, I accidentally.
You got lost in your handwriting?
I just multiplied 24x by 38.
That's fine. You just eliminated x, then you solve for y. That's fine.
But how can you take y and multiply it
18.
by? Oh, you were solving for y.
No, I solved for x. I was getting rid of the. I was going to get rid of the y's.
Oh, well, that's what I meant. You were
Yeah. It's just like I said. There's no right or wrong way to start the problem out. There are many different ways to set these up. Where my question goes? Yes, ma'am. She's so proud of herself.
Do we have homework on this now?
Yes, of course. I think that is right. But I'm not saying that was the answer. -2, 2, 3.
Yeah.
Yeah. Air 5. Where'd my? Here's what I want you to do tonight. It's on. What number is what? It's on page 186, I think. Oh, my post-it note. Oh, there it is. Page 182. Yeah, real quick. What I want you guys to do on page 182, this is section 3.6, 26, 27, 30, 34, and 35. 34 and 35 are two word problems. They give you a chart on number 34 and it asks you to find the price per pound. You will have to work with fractions on that one, but they are not unbelievably scary bad. Use your calculator. 35 is another word problem, but it is very straightforward. You will find out that using some substitution with 35 is very easy. I did figure out why you guys were saying the link was gone to the website. I had to take it off of my school website. So you guys just have to regularly bookmark it or just Google search it. I will send out an email blast again with the link on it. I had to take it off the school website because too many people were linking to it. And I don't want to get busted by the company.
What do you mean? Is this like illegal or something?
It's password protected in case anybody ever asks you.
What?
Oh, so
Oh,
you
I
can't
see
all just
illegal.
get on your website?
So we can.
Yes, sir.